are going to be talking about carbohydrates today. So as far as carbs are concerned, one of the things I want you to know is that carbs help to provide us with energy. Now, if we back up just a minute and think about this for a second, what kind of carbs did people eat, let's say, prior to 1900? Think about people's food prior to the last century. What kind of carbs?
Potatoes.
Potatoes. Okay. What else? Bread. Did they eat much bread prior to the 1900s? No, not much. It was a little bit more difficult to eat bread back then. Okay, so bread, but not a lot of it.
What about like oat,
Lots of fruits and veggies.
oatmeal?
Oatmeal. Okay. Now, next question. Were there any processed carbs?
No.
No, not really. The only processed carbs were the bread. Now we're going to talk about this a little bit later on, not today in particular, but once they started processing the carbs, there became a huge issue. And that issue was that the processes they used to take that wheat and turn it into bread, or like nowadays to take that corn and to turn it into oil, those processes, those chemical reactions that people had to take all this food to go through, actually removed valuable nutrients. Okay? A lot of vitamins were lost, a lot of minerals were lost. Okay? And that's why when you see bread, for instance, you'll see things like enriched with vitamin B. Okay, so enriched with vitamin B12 or vitamin B6 or whatever it might be. They had to add some of these nutrients back to the products because it became a real health issue for us to not have them. I don't know if you saw this article, but it came out late last week, and it's talking about this 13-year-old boy who goes into his doctor's office, and the doctor can't figure out why, but the kid is now blind and deaf. And there's no reason for this at all. Now, this doctor has been this boy's doctor for several years, and he would describe the boy as pretty healthy. He looks good, he's not overweight, he's fairly active, but all of a sudden he's blind and deaf. And what the doctor finally figures out is that the boy is extremely malnourished because he doesn't like to eat anything more than 3 different foods. He eats French fries, he eats Pringles, and he eats candy. And that's it. So then the doctor goes, oh, well, let's do some blood work. And this kid basically has no vitamins in his system at all. And he has way low levels of multiple different minerals. Sodium, potassium, selenium, manganese, magnesium, just a whole slew of minerals that he's seriously low on. So the doctor said to the parents and to the child, you're going to have to change your diet, and we can hope that it brings back your eyesight and your hearing. And the boy's response was, I'm not doing it. I'd rather be blind and deaf for the rest of my life than eat something besides French fries and Pringles and candy. He refuses to eat vegetables, refuses to eat fruit. And as he told the doctor, it's a texture thing. I don't like it. Now, there's a lot of people who don't like eating certain foods because of texture, but that's probably one of the most extreme cases I've ever heard of. And, you know, what's your guess is going to be the outcome for this kid? He's going to die at a young age because you cannot afford to be that nutrient deficient, okay? He's lucky he hasn't had any other types of diseases going on. As far as carbs are concerned, one of the major reasons that we have to consume carbs, and I like to tell you that the best types of carbs to consume are the most natural carbs, okay? So those vegetables that we were talking about and the fruit, the things that are not processed, the things that are closest to nature, you might say, are the best for our bodies, okay? And that would even include breads. So if you wanted something that had a little bit more carb oomph to it, you might be looking at potatoes and brown rice because it's not processed. Those would have a lot of carbs in it if you have somebody who needs more carbs. Now, what the carbs are going to do for us is they're going to provide mainly energy sources, and they're going to provide those vitamins and minerals that we need. But the energy that the carbs provide are what I like to call quick energy. So like, for instance, right now, you're not moving very quickly. You're just kind of sitting there. And as you sit there, you're not really using carbohydrates as your energy source. So depending on what we're doing, the body's kind of cool, it can sort of switch energy sources. So it's kind of like you have a car that can go on electricity, and then it can go on gasoline, and then it can switch to diesel. All whenever it needs to, depending on what kind of environment you're driving in, okay? That's the same thing with our body. If we're doing a lot of movement, maybe we're exercising, running, jumping jacks, I don't care what it is, the body is going to use carbohydrates as the main energy source. If we're not doing much movement or any movement really at all, the body is going to use fat as its main energy source. So it's kind of cool. You're sitting here in class right now, not doing very much movement. Guess what? You're burning fat. That's kind of cool. Except there was this guy who heard something like this and he thought, not very much movement. So he actually found out that, I don't know if you've like stepped on a scale before you go to bed at nighttime and you weigh a certain amount and then the next morning you're like 2 pounds lighter. He found out, well, you're not doing very much movement while you sleep, right? So I lose weight, lose fat while I sleep. So he decided to just keep sleeping. So every time he woke up, he'd pop some sleeping pills and go back to sleep. Now, of course you're going to lose weight like that. But if you continue to do that and you take in no nutrients at all, which is what he was doing, and only sipping a little bit of water every time he woke up, you're going to die. And he did. Now, granted, by the time he died, he'd lost 50 pounds just constantly sleeping.
Wow.
But that is not a healthy thing to do, okay? But that does demonstrate to you that our body doesn't really use the fats while we're running and jumping and moving. It's really burning those fats more while we're sitting still. But now, if we do exercise, the cool thing is that exercise actually causes our metabolism to go higher. And anytime our metabolism goes higher, it requires energy. So let's say that I decide, I get up in the morning and I'm going to go running. I don't have very much time, so I'm only going to do it for 10 minutes, okay, before I have to get ready for work. So I go running for 10 minutes. The nice thing about that is, while I'm running, my body is consuming carbs, okay? But as soon as I'm done running, for the next hour, my metabolism will have increased. And I will burn fat, feed my muscles fat, more fat than normal, for that next hour. If I am able to run for, let's say, 30 minutes straight, I increase my metabolism so much that when I'm done running, for the next 3 hours, it increases my metabolism and I burn more fat than I would have sitting still. So that's kind of the good thing that exercise does for you, besides getting your body, your blood to flow and all that kind of stuff. It does rev up your metabolism and it does allow for greater fat burning, which I always like to turn that around and say, now I get to eat more. That's kind of how I look at things, burn that fat, consume more. I like that. Okay? So our we're going to talk about macro and micronutrients, but, well, we'll talk about micronutrients later, but the macronutrients, the three that we're going to go through over the next 3 weeks, are carbohydrates, fats, and proteins. Okay, so those are our macronutrients. The micro are the ones we were talking about, like the vitamins and the minerals. Those will be our micronutrients that we'll cover after that. Okay, so carbohydrates, if you remember, they come in two forms. You have simple carbohydrates and you have complex carbohydrates. Now, anytime I say carbohydrates, you could substitute that for sugar. Okay, now I don't necessarily mean the stuff you put in your iced tea only. Any type of carbohydrate is also a sugar. So when you talk about corn being filled with carbohydrates, you could also say corn is full of sugar. So sometimes I see, like on nutrition labels, it'll have total carbohydrates, let's say 23 grams. And then under that, it'll say sugar, 5 grams. Or I've seen it like this, where it's sugar-free candy. And it'll say sugar, 0 grams, carbohydrates, 56. That is so lying to the person who's buying that, because it really is 56 grams of sugar. Okay? But the government allows those nutrition labels to say carbohydrates and to say sugar, and to kind of fool the average person into thinking something totally different. So when you're reading the nutrition labels, sometimes the sugar is added into what they call carbohydrates, and then you'll have net carbohydrates. And sometimes the sugar is not added. So if you're trying to see how many grams of carbohydrates are in a food, you may have to add the sugar and the carbohydrates, because that will give you your total carbohydrates, okay? So simple sugars come in the form of monosaccharides and disaccharides. And then complex are called polysaccharides. Okay? So a monosaccharide, and I don't really care if you know this, you don't have to memorize this, but it has a structure like this, C6H12O6. So that'd be like glucose and fructose. Those are monosaccharides. You might have heard of like deoxyribose sugar, that's part of our DNA, or ribose sugar, that's part of our RNA. Those are single molecules of a carbohydrate. Now, if we bond two monosaccharides together, we have a disaccharide. So for instance, if I bond glucose and fructose together, what do I make? Sucrose. Excellent. That's the sugar you put in your iced tea, right? Okay. So fructose and glucose make sucrose. You might have heard of like lactose. That's a type of disaccharide, and that's a milk sugar. Okay. Polysaccharide. This is where you take hundreds and hundreds of glucose molecules and all bind them together. And that makes a polysaccharide. Okay. Now, you've probably heard of a polysaccharide that is produced by a plant. We call that starch. So this is why when you eat a potato or you eat a bread product, there is a lot of carbohydrate in that. Because what happens is this starch, hey, she just misses me, so she wants to come in. This starch is what the plant stores for its own energy, okay, for it to be able to grow and everything. It stores a whole bunch of glucose, and so when you eat that plant, you're actually eating a lot of glucose, okay? You get a ton of energy from a single potato. Now, the problem with Americans is we all think starchy foods are horrible for us. You should not eat starchy foods, they're terrible. That is absolutely 100% not true. There's nothing wrong with you eating a potato. But here's the problem. When you turn that potato into a potato chip, yes, it just became terrible for you. Okay? You took all the nutrients out of it and turned it into a potato chip. And I don't know about you, but I could eat a lot of potato chips in one setting, okay? I get that bag and all of a sudden I just keep eating and eating and eating and I forget I'm even eating it because when I processed that potato and turned it into a potato chip, I took most of the nutrients out of it. And so I have to eat a ton of those potato chips to actually feel full because I don't have enough nutrients in those potato chips. So now we go, oh, starch is bad. But we're eating the starch not in the natural form. We're eating it in the unnatural, non-nutrient form, and we're eating too much of it. How many of you can sit and eat that many potatoes compared to that potato chip? So, I mean, I could eat like a whole bag of Lay's potato chips without a problem, especially those cheddar ones. Oh, I love those things. I swear I could eat the whole bag. But how many potatoes do you think it took to make a bag this big? Well, it takes a lot of potatoes. I could not sit at one sitting and eat that many potatoes. You see the difference? So if I eat that bag of chips, I can get far too many carbohydrates. And then what happens? If I have far too many carbs in my system, what my body does is convert that to fat. It's a really good way of my body storing excessive amounts of carbohydrates from my diet. Because my body isn't wasteful. If I feed those things to my body goes, she must want me to store this away. No problem. Okay? Now, originally, if I eat carbs, but not excess, okay? I'm just going to eat a potato. Two things are going to happen with those carbs. If I go exercise, I'm going to convert that into energy, okay? But if today isn't a day I really need, or I really have time, I should say, to go do exercise, then my body's going to go, okay, well, she doesn't need it for a bunch of energy, so let's store it away. But she's not eating excess carbs, so we can't store it as fat. Here's what we're going to do. We're going to store it as a different product, and we're going to call this glycogen. Glycogen is a polysaccharide. It is made up of a bunch of glucose molecules, and we can store this in our liver, and we can store this in our muscles. Which totally makes sense because if now I go to exercise, I have plenty of carbohydrates to feed my muscles so that they can keep doing that energy thing and I can keep going. I'm only going to take the carbs and make it into fat if this is excess carbohydrates, turning it into fat. And unfortunately, that's really kind of the American diet. We have all these carbs hidden in so many foods that we eat, we don't even realize how many carbs we're eating. So like this morning, I taught a physiology class, and one of the things that I asked the class to do is just to go home over just one day and look to see how many carbs, don't change your diet, don't do anything different, just look to see how many carbs you eat in a day. My guess is going to be the average student in that class is going to eat about 500 grams of carbs a day. That's going to be pretty much the American average. What is the average amount of carbs that an adult typically needs in a day? Now, of course, this is an adult, and this is somebody who's not doing tons of exercise. So we're not talking a marathon runner or an Olympic athlete. They're going to need more. It's about 100 grams of carbs a day. And if we have somebody who is overweight, it's probably going to be less than that. And then we'll talk about it too. If they're diabetic, you're going to even need less carbs than that. So people with diabetes, you don't want nearly as many carbs in their diet. Okay, so we've already talked about all of this. Yes, ma'am.
So glycogen is stored in the liver and muscles?
Yes.
Oh.
Yes.
And
So, I'm sorry, go ahead.
glycogen is basically polysaccharides?
Yes, glycogen is a type of polysaccharide. And this is many glucose molecules.
Type.
Okay? And that makes up glycogen. And that's what a polysaccharide is. Okay? And it's the same thing. Starch is the same thing. Starch actually is the same identical chemical structure as glycogen. It's just glycogen is in an animal and starch is in a plant. So we just give it two different names so that we know if we're talking about a plant or we're talking about an animal. Okay? But these are carbohydrates. It's just a lot of glucose molecules all in one thing. So the reason that plants need this is because you know they go through photosynthesis and they're going to take the sun and they're going to take carbon dioxide and they're able to turn all of that, which is kind of cool, into glucose. And then they bond all those glucose molecules together and it's stored in the plant as a form of starch. And so this is the food of the plant. So of course when we eat the plant, we get that starch. And then of course some of the other things that we might get from a plant is fiber, and we'll talk about that in a little bit as well, which is very helpful for the body. So we consume the plant and we get the carbohydrates out of it for our energy as well as some of the fiber. So here's a picture of a monosaccharide. For instance, this is glucose, and then we have fructose, galactose, and then monosaccharides occur in things like honey or dried fruit. Raw fruit has a lot of fructose and glucose in it. High fructose corn syrup, you've probably heard of that, where they take corn and they put it through a process and they make this corn syrup. And they're able to convert the corn not into glucose but actually into fructose. And fructose is much more sweet tasting to us than glucose. And it's thought that it becomes addicting for us when we start to eat high fructose corn syrup. There are a lot of people who are very concerned scientifically with the fact that high fructose corn syrup triggers cancer. And there is quite a lot of scientific research to show that if you want to kill cancer cells, starve them of carbohydrates. So decrease the amount of carbohydrates your patient is consuming and decrease their risk of cancer metastasizing. So that's kind of interesting. And then this high fructose corn syrup is actually much easier for our body to convert into a storage form of fat. Disaccharides, we talked about that. Lactose, sucrose, maltose, those are all types of disaccharides. And so here you go, glucose plus galactose equals lactose, the milk sugar. 2 glucose molecules equals maltose, which is found in different types of starches. And then glucose plus fructose, we said this is sucrose. So this is your sugar cane and your sugar beets, all that kind of good stuff. These are just some different examples. Now, polyols, we'll talk about that a little bit later. These are found naturally in fruits. And so polyols are like alcohols of glucose. And polyols are not used the same way for our bodies. So those alcohol sugars, is what it's typically called, would be things like stevia, that's a type of alcohol sugar, or mannitose, which is a type of alcohol sugar. And our body doesn't have an insulin response to these types of sugars, which is a good thing because one of the other issues in America is that we are burning out our pancreas really quickly because we're making our pancreas produce too much insulin too often in a day. So, you know, you have an average American who eats a ton of carbs for breakfast because they're having cereal or breads, some kind of sugary donut, I don't know, whatever it is. You have a ton of carbs for breakfast, and as those carb levels go up, those sugar levels in the blood go up, and of course insulin has to be made. And then it's around 10 o'clock, now I'm hungry, so I'm going to have more carbs. And I don't know what kind of carbs they are. Maybe I'm trying to be a little more healthy, so I have yogurt. But that's got a lot of carbs in it because they add all that fruit and whatever, and sometimes even high fructose corn syrup to that yogurt to make it taste really sweet. So you have to be really careful. And now, a couple hours later, I've spiked my insulin levels again. And then a couple hours later, I have lunch, which is mainly all carbs, and up goes my insulin. And then I have another snack, and up goes my insulin. And then at dinner, up goes my insulin. And then I got to have a late night snack while I'm watching television or studying, right? So up goes my insulin again. And I have these massive insulin releases because I'm not eating a little bit of carbs. I'm eating 500 grams of carbs a day, 5 times what I should be eating in a day. And so I'm producing 5 times the amount of insulin that I'm eating in a day. So what they've done with some foods is they've started to add these sugar alcohols that don't cause the insulin spike. And so it doesn't burn the pancreas out quite as quickly. However, be a little bit careful if you start to eat some of these sugar alcohols because they also make your bowels move very well. So you've got to be a little bit careful of that. You won't have constipation, all right? I can promise you that. Yeah, question?
I was gonna ask, what about if you're eating like fruit that's carbs? Does your insulin level still rise from that type of carbs, or it's
Excellent question.
just
Not as high.
not as high? So it's okay.
Because, okay, let's think about this again. Your average Snickers bar, okay?
Right.
Average Snickers bar is about 56 grams of carbs, right? How many carbs is in an apple? Give me a guess.
30.
In an apple?
13.
Depending on the size of the apple, about 8.
Fine.
See the difference?
Right. Okay.
Now, say it again.
Oh, I thought it was a lot more.
Nope. A banana, 30.
Wow. Really?
Bananas, lots and lots and lots of sugar in bananas. So if you're watching your sugar, eat less of a banana.
What type of apple?
Yes, depending on the size, depending on the type, yes. So just as an example, if you eat, I don't know, my kids love Granny Smith, okay?
I
So
do.
if you eat a Granny Smith and you get 8 grams of carbs in a Granny Smith, how many Granny Smith do you have to eat in order to equal the number of carbs in a Snickers bar? Yeah, you have to eat 7 all at one setting to get that kind of insulin response.
Okay.
Who's going to eat 7 Granny Smith apples, all one right after the other?
No.
A nut. Okay.
I ate like 2 maybe. That's
Yeah.
why.
It's just not going to happen. But how easy is it to eat a Snickers bar?
Yeah.
Super easy. Man, I can do the king size with no problem.
If you're saying that carbs and sugar are interchangeable, so
Yes.
when you're looking at the nutrition facts on something, are you just adding the two together and that's essentially telling
Sometimes the label already does it for you, and
Okay.
sometimes it doesn't.
If-
But yes, you want to add them both together to get total carbs.
If they're labeled 2 separate times,
Yes.
right? Okay.
Yes. Okay, so oligosaccharides are kind of in between a disaccharide and a polysaccharide. So they're actually short chains of carbohydrates, okay? So this is like 2 to 10 glucose molecules. You get what's called maltodextrins, and then you have another type called raffinose. Now, these are mostly, we come in contact with these because the food industry adds these to processed foods. And so when you eat these in plants, you don't get a lot of them from the plant. So if I eat peas or I eat beans, I don't get a lot of these in the peas or beans. But here's one of the issues though. The food industry adds a lot of this to our food because they want to capture the people who have texture issues with their food. They want to give certain textures to food because if your food has a particular texture to it, you're much more likely to eat it. So this is another kind of hidden way that they can add carbs to your food when it's not even necessary to do that. They're manipulating the food in order to grab you and make you want to eat those foods more. So we talked about starch and glycogen. Now, there are 2 other types of polysaccharides I want you to be aware of. One is called amylose, and the other is amylopectin. These are types of starches. So it's still a starch, it's a polysaccharide, but they have very particular names depending on the structure of the polysaccharide. Okay? Amylose and amylopectin. So amylose is a long straight chain of glucose molecules, and it's found in vegetables. Now the really big deal about amylose is it is about 20% of the digestible starches that we eat, and then amylopectin makes up the remaining 80% of the types of starches that we eat in the body, and amylopectin is more of a branching type of look. So if you look at amylopectin, it has more of this kind of a look to it, where amylose is just a straight chain made up of individual glucose molecules all bonded together. Okay? Amylopectin, these are all glucose molecules, but they make up this kind of funky chain-like pattern. Okay? So amylopectin is branched and provides many sites for enzymes to break these down. It's really easy for us to digest it, but it also can raise our blood glucose levels more than amylose does. So show you the difference. So this is amylose, the straight chain with all these glucose molecules. This is amylopectin with the kind of branch chain. Looks very similar to glycogen. Okay? And then notice this is fiber. Lots of these chains all together. So we talked about glycogen. Now, one of the other things I didn't mention is that glycogen in our liver, we are constantly, even though it's stored in the liver, we are constantly releasing small amounts of this glucose into the bloodstream all day long. Now, that's okay because it helps to keep up our energy levels and we feel better about it. But this becomes a real problem for our people who are diabetic. So releasing this glucose into the bloodstream makes it potentially harder for them to control their blood glucose levels, and especially in the morning, because the liver releases more of this glucose in the bloodstream in the morning, and people who are diabetic have a tendency to have higher blood glucose levels in the morning, much more difficult to control. So the pharmaceutical companies came up with a type of medication called Metformin, also known as glucophage. And what Metformin does is it prevents the liver from breaking glycogen down into glucose, so that glucose cannot be released into the bloodstream. That helps people who are diabetic to keep their sugar levels lower. Now, there's a little bit of controversy with metformin. There's been one study that says that metformin increases your risk of liver failure. However, there have been multiple other studies that haven't been able to show that. So they're still using this medication, and it looks to be safer than they originally thought, which is a good thing because it's really one of the only medicines out there to help people who are diabetic besides the insulin. And sometimes they need both. And sometimes you give them metformin before you give them insulin in hopes that they won't have to have the insulin, which is a little bit bigger step for somebody. So we talked about starches. Now, one of the other things is that some starches are indigestible. That means we don't have the ability to digest these starches in our system. So one of the types of starches that I want you to know about is called a modified starch. These starches have been modified by the food industry. So either by the chemical processes we were discussing or by plant breeding. So you know that there are a lot of genetically modified plants out there now. And one of the ways to modify these plants is to make sure that the plant grows in such a way it actually produces more starch than it would have in its natural state. So one of the things with this is it reduces how stale or how quickly something is going to mold. So these modified starches help to preserve the foods. Also, used to be if you froze something and then you defrosted it, it was not a good idea to freeze it again. But nowadays, because they put these modified starches in, you can freeze and defrost and freeze and defrost and freeze and defrost and nobody cares. And I don't know about you, but I've like had a loaf of bread in a drawer for 6 years and take it out and it's not moldy yet. Just seems like there's something wrong with that. I don't know. It's just disgusting.
So it's okay to defrost meat and refreeze it again?
Yes. Because they actually powder meat in this modified starch.
We powder meat, and that's all types of meat?
Pretty much any type of meat is powdered in this stuff.
Wow.
Now, it depends on how long you've left it out, because if you leave it out and you've got any kind of bacterial growth, then no, probably you don't want to do that. Unless you freeze it really cold, and then it will kill the bacteria.
Oh.
So amylose and amylopectin in starchy foods alters the nutritional properties and the other functional properties of the foods, and this is happening in genetically modified foods. So what they're doing is they are genetically modifying this to increase the amounts of amylose and amylopectin in our foods so that it decreases staleness, decreases moldiness, and allows you to have particular textures to your food. Okay, so the fibers are a type of polysaccharide, and let me go back to that picture again so you can see this. This is amylose, and so these are the long chains of amylose making this type of fiber. Okay. Different starches, because of their chemical bonds, can't be digested by humans, and it can't be absorbed through the small intestine. So when we eat these different types of dietary fibers, they stay in our intestines. So they go through the stomach, they go through the small intestines, they can't be absorbed into the bloodstream, and they end up in the large intestine. Now, why this is important that we can't digest certain types of fiber is because two things that fiber does for us. Number one, the fiber actually bonds water. Water is very attracted to fiber. So if the fiber ends up in our feces in the large intestine, water will stay in that feces. If you don't have a lot of fiber in your diet, that water actually is absorbed from the large intestine into the bloodstream, and the water doesn't stay in the feces. And that increases the likelihood of constipation for the person. It also increases the likelihood that the feces can become very dry. Okay, now here's what happens when you have dry feces. As it's moving through the large intestine or the colon, it scrapes up against the walls of the colon. And over time, it can actually cause divots in the walls of the colon. So it literally creates these pockets all throughout the walls of the colon. And you can have patients who have thousands of these pockets in the wall of their colon, and it decreases what we call the integrity of the wall of the colon. So the colon could actually split. And that releases feces into the body, and this is bad, okay? You're going to have a hard time saving that patient. But before that ever happens where the walls break down, what's going to happen to your patient is they're going to have a disease called diverticulosis. Diverticulosis is the actual pits or crevices in the walls. So you start to get those, this is not good. Because now the next thing that could potentially happen is food gets stuck in there, or feces get stuck into those little pits. And naturally we have bacteria in our colon. So that bacteria with that food gets stuck in the pit and it starts to become infected, and now your patient becomes extremely sick. If it becomes infected, now it's gone to diverticulitis. And for most of your patients, what's going to happen is they're going to have to go through surgery and have a part of that colon removed that is infected. And so that's not necessarily good, because now they're going to have a colostomy, and yeah, it's not a lot of fun. So one of the places we get this dietary fiber would be like from bran, okay? Other types of whole grains have a lot of dietary fiber in it. If you didn't want to eat those types of foods, then you could also get them in prunes. Prunes are very high in dietary fiber. That's why in the hospitals, when your pregnant ladies give birth, one of the biggest issues for them is having constipation. You don't want them to have to push at all, because that's very painful. And so it's highly recommended for your new moms to have prune juice. So everything flows out easy and it's not so painful for them. Okay, so non-starch types of fiber, or non-starch polysaccharides. These would be like cellulose, xylose, and mannose. And these are also part of plants. They are polysaccharides that make up the cell wall of the plant cell. Pectin is a type of fiber. Now, I don't know if there's any of you who make jellies or do that kind of canning, but pectin is usually added to jellies, and what it does is it makes them a little bit more stiff and not as watery and gel-like. But pectin also comes from cell walls. There are different types of plant gums that are used, and one of them would be like guar gum. And guar gum comes from what are called cluster beans, and these are used as thickeners in things like your salad dressings and soups. They use guar gum in like toothpaste to not make it runny. Okay. And algae. This is a type of polysaccharide, and so they extract algae, and they use seaweed, and they make what's called carrageenan. And carrageenan is not good. You do not want to eat things that have carrageenan in it. It has been shown to cause all kinds of problems in the human body. So inflammation, bloating, irritable bowel syndrome, glucose intolerance leading to diabetes-like symptoms, colon cancer, food allergies, bad stuff. So you'll see on some products, it'll say carrageenan free. So like a lot of your coffee creamers have carrageenan in it to thicken the coffee creamer. So you want to make sure you're buying your coffee creamers carrageenan free. So another type of fiber is called a resistant starch. And this is also considered a dietary fiber, so this is something that we eat naturally. And this helps to increase our ability to deal with glucose. So certain types of fiber that we eat, that we get from plants, actually allows us to lower the amount of glucose in our blood. And usually this is going to come from vegetables. So the fiber that we're getting from vegetables, and even this would include oatmeal too, as a matter of fact, if we eat that fiber with a high carbohydrate meal, it can actually lower the amount of glucose in the bloodstream. So remember, fiber can't get into our blood. It stays inside our intestines. And for every gram of fiber you eat, it holds on to a gram of carbohydrates and prevents it from getting into your bloodstream. So if I eat 10 grams of carbohydrates at a meal, and I eat 5 grams of fiber at the same meal, I'm going to keep 5 grams of those carbohydrates in my intestines, and only 5 grams of carbohydrates will get in my bloodstream. So when you have a person who's trying to decrease their blood sugar levels, one of the things you tell them is make sure you're eating fiber with every meal, so that you don't get as much blood sugar going in, or sugar going into the blood all at once. You don't get that bulk movement. It keeps the insulin levels low, keeps the sugar levels low. So fiber doesn't give us any energy because, like I said, we don't have the ability to digest it. But 2 kinds of fiber, soluble fiber, insoluble fiber, just if you ever hear those terms, it just means it can dissolve in water or it can't. So if we call something soluble, insoluble, it can or can't dissolve in water. But if it's insoluble, okay, we have a lot of water in our system, a lot of water in our intestines, that means it definitely is not going to be able to be broken down on the way to the large intestine. So soluble versus insoluble, when the soluble fiber, which can dissolve in water, gets to the large intestine, bacteria and different things can work on it to help to make it ferment. So sometimes when you eat a lot of that soluble fiber, you might get a lot of gas going on from the bacteria. But that's also actually really good for our intestines, because the bacteria working on that releases chemicals that are very healthy for us. Like, for instance, some of the bacteria is going to release things like vitamin K, which we'll talk about later, that helps us be able to clot our blood. But there's a number of other chemicals that the bacteria, as long as we feed it this soluble fiber, it's really happy and gives us a whole host of chemicals. One other thing that soluble fiber is thought to do, but not totally for sure able to do, the soluble fiber is thought to help to keep our cholesterol levels lower in our blood. So similar to the fact that it helps to keep the glucose from getting into the bloodstream, it also helps to keep excess amounts of cholesterol from getting into the bloodstream. Now, there's not a lot of research on this, but we find that the Scottish people eat a lot of soluble fiber because they eat a lot of oatmeal. And they actually have very low levels of cholesterol as a whole for those who eat all the oatmeal. They also have very low levels of colon cancer. So this soluble fiber also helps to keep their colon nice and happy and healthy too. The insoluble fiber, it helps to increase the bulk of our stool, and it helps to relieve constipation. So what that means is it's helping to keep all that water in the stool. But the interesting thing is, for some reason, and nobody really understands this very well, is it stimulates peristalsis of the colon, which is the movement of the muscle needed to move the feces around so that we can get rid of that waste. One other type of fiber is called a functional fiber, and we get this from something called psyllium seed husks. This would be like Metamucil. You've probably heard of that. This is a type of fiber very similar in function to insoluble fiber. It's going to help with stool and movement of the stool by peristalsis. All right, so it is 2:55. Let's take a break and we'll come on back. Let's take 15 minutes.
Okay.
You try to forget that too.
Yes, yeah, we're gonna give you a teaspoon. Oh, yes.